giving this same talk in a few days at the DevOps conference, but we wanted to show it because
it's creepy.
We thought it would be a more true representation of what the evening will actually be like.
Actually, is anybody going to DevOps next week? Okay, also sorry, just don't go to see that talk again. It's going to be very boring. It's probably going to be the same slides.
We should rename it. It'll be What's Not New in Android Anymore.
Unless you boo or tell us that it was really bad and maybe we'll change the slides. No. So, hi, I'm Romain, former member of the Android team. Now I'm working on a new super secret project, kind of at Google. And this is Chet, who took my job.
I think he gave it to me, and when he left, we gave him a nice card that gave him a new title, which is Traitorous Bastard.
Yeah, I was jealous of seeing him. It actually did. I was jealous of seeing him write code, so I gave him my job, so now he doesn't write code anymore.
I go to meetings for a living. So tonight, we thought we would talk about candy.
So Android 4.4 KitKat, that was announced, when was that announced? Last week, I think? Trying to remember. Sorry, we landed a few hours ago, we're still jet lagged and tired. And honestly, we spent the whole day trying to finish up the slides. Anyway, and one of the traditions we have is after every major release, Chet and I give a talk entitled What's New in Android? And of course, we're going to focus on Android 4.4. So we actually wanted to talk a little bit about what was new in Android 4.3 that was announced this summer. But turns out there's so much stuff in 4.4 that we won't talk about 4.3 at all. So if you haven't seen everything there is to see in 4.3, there were very interesting Google I/O talks that are all available for free online. So you can go check them out. And some of the things we're going to talk about are improvements over things that were new in 4.3. All right. At the same time as Android 4.4, I'm sure you've heard about it, we've announced Nexus 5, which was probably the most leaked device ever. So I won't go into too much details. I'm sure you guys know everything there is to know about it. If you haven't seen one, Chet and I have the white version and the black version, so you can go take a look during the break.
Here. Oh, we can hold them up. Here. You can see them in real scale. Here.
It's a big device, but it's not that big.
Just so you didn't think we were lying about what they did. They're just a little smaller than the slide indicates.
Anyway, it's a pretty cool device. Now Chet's going to talk about numbers. He loves to do
that. Let's start with a lot of zeros. So apparently, this many devices have been activated already, which is a huge, not only a huge number, but a huge increase from where it was, what, a year ago?
Yeah, a year ago, the number of activated devices was 500 million. So we doubled that number in a year.
So I think, if I'm doing the math correctly, in 4 years, everyone on the planet will have an Android phone. And then we'll just have to expand into space because we have no choice. That's where the market is. We track activation over time. And this is, wait, you made this graph. I like the little hockey stick at the end. Tell me about it. Go.
It's an awesome graph. You guys buy a lot of phones.
There we go. There's a lot of device activations over time, and it keeps getting more and more and more until we reach the population of the planet. We haven't figured that one out yet, but we will.
Well, that's why Google, we announced this new company called Calico, which basically aims at making people live forever, because that's the only way we can keep growing Android.
So where'd you get this data? On the developer site? So you can see the breakdown per release. So if you as an Android developer care about what APIs you're targeting and what part of your user base you may be cutting out, and you're writing really old crusty Froyo code, then maybe it would be time to stop.
Or if you're writing code that's only for Honeycomb, I don't know what you're doing. So Honeycomb shows up on the graph, it's 0.1%, so it's very tiny. I don't know who those people are.
I think it's my Zoom. That's it. I have a Zoom tablet, and it's right there.
Yeah, but it got the upgrade to SCS, so you must say no every time it does an update.
Gingerbread is still a significant portion, although getting smaller, and we'll talk a little bit later about why this should be getting even more significantly smaller over time. I'm going to have a hard time getting through the hour here. I'm so incredibly tired. My brain is dead. So the breakdowns that you really care about are basically what's gingerbread and below, and this is kind of where it's at right now, and hopefully getting even better over time. And now let's talk about APIs. This is, so the stuff that we just talked about, that's sort of, user-focused Android, but the real reason that we give these talks is the more interesting part, which is what are the developer features that you can take advantage of in your application. So let's go through a whole slew of them. First of all, there was a couple of important features in the area of documents, such as?
So that one is actually a feature both for developers and users. We've unified storage access. So if your application wants to, let's say you're writing an email client and you want to attach a picture or a document, now we have a new UI that you can invoke from your application that will list all the known documents providers. So we have a single point of entry for all data on the phone. And there's even an advanced setting, so you can check a box, and we're going to add the internal storage item in the list, so you can browse the entire file system. So you don't need a file explorer or anything like that. It's built in now. So by default, some of the applications that come with the phone, like Google Drive or Gallery, will show up in this list. But you can also add your own applications. So if you want to invoke that UI, you can use two intents. There's the action open document, and which it's pretty clear what it does. So you just want to attach a picture to an email, so you're going to use open document. You can also use action create document to bring up a similar UI and decide what application you want to use to create that new UI. You can also set the type of file that you want, so you don't have to see all the providers. So you can limit your the view of the file system to just the images, for instance, or just Word documents. You can also write your own provider for this new API. So it's pretty simple. You have to extend a new class called the documents provider, and there are only 4 methods to implement. So the first one is called query roots. You just return basically an array of, actually a cursor, sorry, a cursor of the top level directories in your virtual file system. So the files don't have to be on the phone; they can be in the cloud. So if you're Dropbox, you can use this API to just show documents from the cloud. Query child documents will just list the content of a given directory. Query documents is to perform searches, so if the user is looking for a particular type of document, that's what we're going to invoke. And finally, the open document, probably the hardest one to implement because you have to use file descriptors and parcel file descriptors. This is how you return an actual stream of data to the calling application.
So there's more methods that you can implement, such as actually allowing people to create a document with your provider as well, but this is sort of the basic level. If you just want people to actually view and see and search and open your documents, this is where you start.
And because it's a provider, you have to register your provider in the manifest. You have to use the intent filter called documents provider, and you need that new permission that you can see at the top, manage documents. Everything else is very similar to other types of providers.
So the other large feature in the general bucket of documents was printing. Hey, you can now print from Android using Google Cloud Print, as well as printing on Wi-Fi for printers that are enabled for that.
Yeah, so we have an example here in the screenshot on the left. By default, Nexus 5 comes with support for Google Cloud Print and also HP printers, which was nice because I happen to have an HP printer, so I was able to print my tickets from my phone. It actually works. That's pretty awesome.
So there's, it's not that hard to deal with. We take care of a lot of the plumbing in the printing feature itself. The protocol that we use for talking to the printer is PDF. So basically, at the bottom level of all this stuff, we generate a PDF document that gets sent over to the printer as the sort of common transport.
So that's actually interesting for a lot of applications, because even if you don't want to print, you might want to be able to generate PDF documents to email them or just save them somewhere on the phone. And this is the API you can use. It's pretty nice. So you just create a new PDF document. You create your pages, and when you have a page, so if you look at view content equals get content view, you can get a canvas for each page. So anything that can draw on the canvas, so a view or any type of API that takes a canvas as a parameter, will be able to render in a PDF document. There are a few limitations that are documented. You can go to d.android.com to see those limitations, but it's really some of the really advanced APIs of Canvas. So if you try to do perspective transforms, or you're trying to use advanced filters, they're not going to work. We're going to improve the support in future versions. But that's all the code you need to be able to successfully generate a PDF in Android 4.4.
And these are just the normal drawing commands that either you have or the standard widgets have. When you call draw on that with a canvas, then the normal path of rendering when we display stuff on the screen is going to be called, but instead of displaying on the screen, it's going to end up in this PDF document.
So yeah, if you want to quickly add printing to your application, you can just tell the views in your UI to print themselves on the PDF document and you're done. Using the low-level API for PDF printing can be a little difficult. So for instance, if you're trying to print a large image, you might have to split the image into several pages and you have to deal with the margins and all that stuff. So for very common use cases, in particular bitmaps, we provide a helper class that does everything for you. So you create a print helper, you tell it how you want to scale the image, so scale mode fit, it will make sure that the image fits on one page or more. And then you call print bitmap and it will take care of everything for you.
Do you have to call it untitled image?
You can call it whatever you want.
We think of everything.
Well,
okay, user interface. Let's talk about some graphic stuff. So translucent system UI, you will see these if you look at the launcher and home screen on the Nexus 5. So you see the status bar up there and the navigation bar. You can actually see through to the wallpaper below. So these are already enabled on the system for our applications, like Launcher and all apps. But you can also enable them for your applications if you also want to go full screen but have navigation and status bar over.
And I should add that this is, there's no guarantee that your device will use translucent bars. For instance, the Nexus 10, because of very, very specific hardware limitations, will not do the translucent bars. So you might want to be careful when you use them to make sure that performance remains good.
So there's a couple of themes that you can opt into for this behavior, as well as the desire to actually bleed out to the edges and have the translucent bars override your content.
Yeah, to be more specific here, so when you request the translucent bars, your window, I mean, on Android, the applications windows have always been under the status bar. There was always this little bit of extra wasted space at the top where you could never draw. It was always hidden by the status bar, but the window was never under the navigation bar. So now that you can go under both, you really don't want your content to be under the status bar because it's going to be really hard to read your text if there's all the notifications on top of it. So if you set fit system window equals true on part of your layout, the system is going to apply padding and margins to make sure that that particular piece of your layout is not under the navigation bar and the status bar. So if you take the example of Launcher again, you can see that the wallpaper, so the wallpaper extends under the bar, so you can think of that as your window background. But the actual content of the launcher, where we have the icons and the search bar, use fit system window to ensure that this remains visible. Now, if you go in the Google Now section of the launcher, you're going to see that Google Now itself, when you scroll, will extend, will go under the status bar, so you will have overlapping content. So it's up to you to, depending on your content, you may or may not want to use that feature.
We also have immersive modes. So we had variations of this in the past where, let's say, if you're playing a video, you want to, you have lights out modes, or if you're playing a game, wouldn't it be nice if you could actually hide the controls? The constraint was that we want the user to always be able to navigate. They don't necessarily want to be stuck playing Candy Crush forever. Maybe they do actually, but they shouldn't. So we made it so that when the screen was touched, when the user interacted with the screen, if the controls were hidden, they would pop back up so that the user could get the hell out of that game finally. What we've done now is enable this mode where we make it clear to the user when the bars go away how they can get the bars back. There's common patterns where they can swipe the navigation bars back, but they will stay hidden and allow you to interact with your game. If you have a 3D immersive game, it's nice if they can actually interact with that game without the bars popping back in. So you can enable this in your application now. And there's a couple of different ways to do this. First of all, the key flag is there, well, full screen already existed, right? But it's the immersive mode itself, and then there's another tweak on immersive mode that you can add as well. So adding the immersive mode says, I want all the bars to go away.
Yeah, and as you can see, so this is a method that shows you what code you have to use to hide the entire system UI. And you can tell by the number of flags that it is very easy to come up with the right set of flags. So make sure if you want to do that, just copy that code. Don't try to figure out the flags by yourself. It makes sense when you spend an hour reading the documentation.
And this variation?
And this is to, yeah, so if you want to toggle the UI back and forth programmatically, this is the show system UI method. It's a little simpler, but same thing, like, just use those flags and it will work just fine for you.
And there's an additional flag here, which is sticky. There's actually a bunch of internal debate over the correct name for this one. I think we went back and forth. But the key is sometimes you want the interaction to be when the user has requested these bars, then I want the bars to go away after a few seconds of not interacting with them. If they didn't navigate away, let's get them out of the way and keep playing the game or whatever it is, keep playing the content. But sometimes that should be an indicator to your app that the user wants to be more interactive with the system overall. So you can set the sticky flag, which means, I think this is the toggle that actually makes them go back. The behavior is get out of the way automatically if there's no more interactivity going on. Otherwise, they will stay. When the user's brought them back on, they'll stay until there's some other event that sends them away instead.
So to make sense of all those flags, here are a few tips. So if you use the flags full screen and hide navigation, it's typically for video players. When you're in a video player, all you care about is playing the video, and if there's an accidental tap on the screen, you certainly don't want to stop the video or start scrubbing, like jump all over the place in the video. So the first tap will not be handled by the application. It will bring back the system UI, and then the user will be able to tap on your UI and you'll get events. Now, if you use those two flags and you add immersive, the user will be able to use a system-wide gesture, so you can swipe from the top or from the bottom edges, and that will bring back the system UI. And then the system UI will stay there. So a good example of an application where you might want to do that is a content reader, like an RSS reader, a books reader, a magazines reader. The idea is that you're reading and you might want to go change the font size, or you might want to go buy another book. So you bring back the UI, and the UI will stay there until you tell it to go away again. Now, if you're writing a highly interactive application like a game or a drawing app, you're going to use immersive sticky. That means that when the user, like all the touch events in full screen mode will all go to the application, which is exactly what you want for a game. And then if the user brings back the system UI by swiping up from the top edge or up from the bottom edge or down from the top edge, the system UI will come back, but will automatically go away after a couple seconds to go back in the game because it probably needs you to do something. So yeah, so that you don't die.
Big feature that's been in development for a while is there is a new default web view based on Chrome. So Chromium, thank you. Get my terminology correct. So this gives you the ability to basically stay in sync with the developer Chromium itself. So there's no longer like one web view experience on mobile devices as opposed to Chromium's different way of doing things on desktops. Common code base, it's a good thing. There's also other abilities that it gives you, such as?
Yeah, so one of the awesome features of having the web view based on Chromium is that you can do remote debugging from your computer. So in your instance of WebView, if you call this new method called set web contents debugging enabled, and you set it to true, then you can hook up your device over USB. And in Chrome, you just go to the URL. Sure. In Chrome, you just go to Chrome //inspect, and then you will be able to use the Chrome debugger. That's what it looks like with your WebView inside your application. So you can do, there's a JavaScript debugger, you can inspect all the elements, you can tweak the style sheets on the fly, you can do profiling, you can see memory usage. All the things were not possible with the old WebView, so it was pretty difficult for developers to tweak their JavaScript, for instance. You had to do it on the desktop and trying to have your desktop work as an Android WebView. So that's a lot easier. But if you use WebViews in your application, make sure to test the app on Android 4.4. It's an entire new code base for the WebView. So there might be different behaviors, new bugs. All bugs might have been fixed. So go test it. And if you do find bugs, please file them at b.android.com, and you can also probably file them on the Chromium bug tracker. The Chromium guys are really, really responsive.
Let's talk about animation. So one of the things...
That's going to take a while, so we're just going to go sit over there.
Everybody just gets up and leaves. You'll find me here when you come back. That's fine. So one of the features that Romain and I were talking about implementing for quite a long time since I came on, I think, was the ability to automatically animate transitions between different scenes of your application. So let's take an example. You've got a simple container. It's got a submit button. It's got an edit text field that has some explanatory text and maybe some other elements on there. And you enter some text. You click the submit button. And then it goes into another state of your application where maybe the submit button and the edit text are still there, but the label went away. You have some other search results that came in. So there's elements that go away, there's elements that come in, and there's other elements that are shared between these. Maybe they're in a different position, maybe they're a different size or a different orientation. Wouldn't it be nice if you could actually animate those changes? Obviously you can animate the changes right now, it's just not obvious how to do it, and it takes a fair bit of manual coding to get there. It's been getting simpler over time with some of the new animation capabilities, but it's still not obvious to people how to do this. So we wanted to try to make it as automatic as possible. So the transition system is basically a way to say, here's a description of what my scene is before, here's a description of where I'm going to next, go. And then automatic animations take place, or you can customize those animations if you want a more custom experience instead. So I'll step through the different modules of this to try to give an understanding of what's going on. First is the idea of scenes. You can think of these as kind of layouts or maybe sub-layouts in your view tree. It's the state of part of your view hierarchy at any point in time. So you can create a scene from scratch. You can say, I want to base a scene on this scene root, and when somebody goes into my scene, I want you to run the following code. And you pass in a runnable, and your runnable would get called, and then you would manipulate the view hierarchy however you wanted to. You can also set it up from a layout resource and say, when somebody goes into my scene, I want you to inflate the following layout and install that into the view hierarchy at the level of the scene root. Or finally, you can create a scene. If you've already inflated all your layout files and you have these view groups sitting around, then you can say, create a scene based on this view group. Okay, so that's scenes. The next step is transitions. These are the things that figure out what to animate and how to animate it. And we have some, when I say some, two, we have two baked into the platform. Basically, the workhorses are what you would generally want, which is we're going to move and resize things that change, and we're going to fade things in and out that go away or come into being. So there's the change bounds, and there's the fade transitions. And then there's also other, infrastructure for transitions that allows you to customize that a lot more. You also have transition sets, so you can set up a choreography of things to happen. I want you to change the bounds of things, and then I want you to fade things out. Or I want you to change the bounds, and then I want you to run my custom animation, and in parallel with that, well, I want you to do these other following operations. So transition set, kind of the parallel of animation set or animator set, a way to group and nest animations. And then finally, you have the ability to create from XML. So all of these things you can create as resources instead. So you can create this transition set out there that says I want to do a change bounds, and I want to do that in parallel with a fade. And then you can inflate that and use it in your in the logic in your code. You can also create custom transitions by overriding these three methods. So there's a start point and an end point. Basically, we need to know what state things are in before, what state things are in after, and then based on the changes that took place between the start and the end, you would create an animator. So you'd set up a transition to listen to, say, the rotation property of views. And when you detect that it changes, then you would create an animator in the create animator method that would run a rotation animation to animate those changes. And then finally, there's the concept of a transition manager, which is it's a holder of the graph of information about when we go between these different scenes in the activity, these are the transitions that we want to run. And this is if you want, the fully custom experience of, well, when I go to this scene, I want you to do this, but when I'm going to this other scene, I want to do this other custom behavior instead. So you can set up a transition manager. You can do this either in XML, set up all the graph of information in XML, and then inflate it using the transition inflator. Or you can do it in code. You can create a transition manager and then manually add these transitions to it. And then there's different ways to actually go into scenes. If you simply say, enter this scene, it will run the code that's appropriate to that scene, and that will be your scene now, but it won't run a transition. All it's going to do is set up the new state of your view hierarchy. If you actually want to run a transition, then you can use one of the static methods or one of the instance methods and say, basically, go into this scene, and it'll figure out the deltas and it'll run some automatic transition. Or you can pass it a transition and it'll run your custom transition instead. Or if you set up this transition manager with this graph of information, then you can say, okay, with this instance of the transition manager, transition into the following scene using the following transition. So all of that was a lot of information, but what you really need to know is there's a single method that you can use in a lot of cases. You basically say begin delayed transition, and then you manipulate your view hierarchy. And that's probably going to trigger a re-rendering, a re-measure, and a re-layout. And the next frame around, we're going to know where it started from, we're going to figure out where it went to, and we're going to start animations based on that, all internally. So in a lot of general cases, if all you want to do is move and resize and fade things in and out, that's the single method that you need. So that's transitions. Was that too long?
No, it's okay.
Should we bring the people back in?
You should ask that. And actually, I think, aren't we using transitions in the action bar now?
Action bar was too general case for transitions. It tends to be a little tricky if you're firing transitions on the same scene route frame after frame. It's a little tricky to figure out what to cancel and what to keep running and what overlaps what for the animation. So the action bar was a little too general case. We are using it in the media transport control view, which is the media player on the lock screen. So you'll see some fading text there, and that's basically using some really simplistic concepts.
But the point is, if you want more animations in your application, anywhere you say add view or remove view, or you change the color of text, or you manipulate the size of something, you can just add that extra line, and you're going to get a bunch of fancy animations for free.
There you go. And I would expect that we will be adding to the capabilities. Right now it's fairly basic. The plumbing is in there for you to customize and do a bunch of fancy stuff. We'll probably be doing some of that internally as well. I also hope that we can add this to the support library. I'm thinking about that kind of right now. But in the meantime, it's in KitKat. Accessibility and I18N, because they tend to be grouped together.
Yes, I think it's the kind of stuff that nobody wants to work on.
But it really has to be
handled. They're very, very important. So in KitKat, we've added a new global setting for closed captioning. So if you can't hear very well, you're probably using that feature already, but it can also be useful if you're watching videos and you can't really use sound. You can turn on closed captions, and then all across the system, video players like YouTube or the built-in video player will be able to render captions in the way you want. So in these settings, you can change the captions to look like the way you want. Here, for instance, you can see I selected white text with a drop shadow and white background. That's now the default captions. You can also specify the language you want to use in captions. So now that we have those global settings, we also made it easier to add captioning to your videos. So if you use the video view, the standard video view, there's not much you have to do. Either you're streaming from an HTTP live stream, and it has built-in captions, and we're just going to display them for you if it's enabled in the settings. Or if you're reading a video from your own data stream, you can specify the subtitle sources. So here, for instance, we have code that adds two subtitle tracks to the video. So we have the English and French subtitles. The format is called a WebVTT. I have no idea what it means, and I don't understand why it says web in it. I guess web is cool these days.
WebVTT.
Yeah, something like that. But that's all you have to do. You don't have to worry about rendering the captions or reading the settings. Now, if you're doing custom rendering of captions because you're using, for instance, OpenGL to do fancy rendering of your video, we have a new captioning manager, and you can install a listener on it so you can listen to any changes in the preferences by the user. And you can get the user style from the manager, so we'll tell you what font you should be using, whether you have to draw drop shadows, what's the background color, things like that. It's very easy to use if you're doing video players. I highly recommend you take a look at those new APIs. It's very important to some of our users, and we are trying to make Android be the best OS possible for people who need the help. Brain fart.
Time for a bit. Jawble's auto mirroring. So there's been a lot of work on RTL in the last couple of releases. First, there was text support, then we worked on the layout support. Right to left. But we have to abbreviate because right to left is so long to say.
Let me ask you another question. How many of you have tested the application for right to left locales? Okay, there's one good guy in the room. Everybody else are terrible people.
It's very easy to test. You simply turn the device over.
Actually, we have something for you in just a couple of slides.
So you can tell us if you, so the general approach with drawables has been to basically create right to left as well as normal left to right drawables, which bulks up the size of your APK. But if you have drawables that actually look good either way, you can tell us that and just provide us with one asset and we'll use it in both situations.
So this is an example taken from the Android framework source code. This is how we do RTL support for spinners. We just added this new auto-mirrored attributes, and automatically the rendering system will flip the asset at draw time. And this is how you do it from code. It's not very interesting, but it works. And to help you test your application in RTL, because there are, I don't remember what the exact number, I think it's between 300 and 500 million people out there who use a locale that's written right to left. So it's very important for you to cater to them and make sure your application works well. The problem was, I don't know about you, but when I run my phone in Hebrew or Arabic, I can't really use the device. And then it becomes really difficult to find a setting where you can switch back to English. So we've introduced in developer settings, there's a new option called Force RTL Layout. It will, so you can stay in English or in French, and the system will act as if you were using an RTL locale. So here you can see the default settings in the right to left mode, but with the English locale. So that makes it very easy for you to test your applications. And most of the time, there's not much to do in your app. So give that option a try and see if your application works well. And if not, we have excellent documentation online explaining what to do.
Performance, favorite topic. All right, so we already had the concept of bitmaps that you could reuse. This dated back to Honeycomb, I think.
Yes, you did that.
Yes. So the idea here is that if you create a bitmap, you'd like to use it as a cache as you load other bitmaps in, so you're not generating garbage along as you go. This was especially important in the Honeycomb release because that was the same release where we boosted the allocation of bitmaps from native code into the Dalvik heap, which means that to get that memory back from the Dalvik heap, we need to do a GC. So it's really nice if you can actually reuse the memory instead of having to collect that every time you load something in, right? So for instance, I saw a screensaver out there that performed horribly as of Honeycomb, or realistically ICS, because on every single frame, it was loading in another frame in the sequence, another image in the sequence, and displaying that. Prior to Honeycomb, it worked fine because it managed the memory manually. It would do a recycle, it would load the new one, it would do a recycle, it would load the new one. Not a real problem. But as of Honeycomb, we had to do a full garbage collection every time. And that's a lot more expensive than simply recycling the native memory. It's very good from one standpoint, but it's very bad from the GC standpoint. So it was important to actually allow people to reuse the memory. But it was very restricted in the way that you could actually reuse the memory. You basically needed to create, you needed to load in a bitmap that was exactly like the one that you created before. It needed to be the same configuration and the same size, the width and the height dimensions, as well as the depth. And people wanted something more like a sandbox, a scratch buffer that they could load things into instead. There wasn't really anything preventing that except APIs and a little bit of engineering. So we did that. So now you can reconfigure bitmaps. You can take the same bitmap that you have, the same memory that you have, and tell it that it is now something different. So here we have a bitmap that's 1024 by 1024, but it's only 1 byte deep, and we're actually changing.
No, it's not 1024 by 1024.
Is it?
The width is 1024 by 1024.
Sorry.
It's 1 pixel high.
Yes. Okay. I'm tired. And we're changing the width and height of that, as well as the depth of that, but it's the same number of bytes. It's okay. All it is a bunch of bytes. So we can now do that and use bitmaps much more flexibly.
And if you look at the last 2 lines, so now we have 2 APIs you can use to query the size of your bitmap. So get byte count will tell you how much memory the bitmap would use with its current configuration normally. So here, for instance, we reconfigured the bitmap to be 256 by 256 and 4 bytes per pixel. So that amounts to about 262 kilobytes. But that bitmap actually lives in a much larger bitmap. So we have this other method called getAllocatedByteCount, which will tell you the actual size in memory that this bitmap is using. So every time you call reconfigure, as long as the new configuration uses the same amount of RAM or less than the allocated byte count, you can do that.
So get byte count already existed. What we did was change the thing that it actually meant, which is it's the byte count of the object that you're accessing as opposed to the byte count that's actually allocated for the object underneath. They used to be the same thing. Now they're not because of this new way that you can reuse bitmaps. But what you can also do is load in bitmaps into this scratch buffer by specifying. So we already had the in bitmap and in sample size arguments that you would use. The new ability here is that you don't have to have a bitmap that is actually the same size and configuration.
And actually in sample size, so in sample size is very useful because it lets you downsample, resize a bitmap as you load it, so you're going to use less memory. And it didn't work before when you were reusing a bitmap, so now it works. As long as the decoded bitmap is smaller than the backing store that you're providing, it's going to work. All right, so that one, I won't go into too much details. I have more explanations on my Go Plus stream if you're interested. So in KitKat, we've created something called the shared assets texture. So on Android, to save on memory, we have the Zygote process that contains data that's shared by all the processes. And what we do in the Zygote process is that we preload all the assets that are commonly used by applications. So things like buttons, like the press state, the disabled state, the normal state, or checkboxes. All that stuff gets preloaded in one central place. So there's one copy for the entire system. The plan was, with hardware acceleration, when you spin up your own application and you have UI, we have to make a copy of those bitmaps into the GPU memory. And every process was making its own copy. So we're using, typically in apps like Gmail, like in a fairly standard application, we're wasting a megabyte or two of system memory per process that was doing UI. So now what the system does is, the first time you boot it up, it looks at all the assets that live in Zygote. It runs through a large number of algorithms, so it tries thousands and thousands of combinations and finds the best configuration for your device, for your resolution, for your current version of Android, and packs all those assets into a single texture, and all the processes are going to share that texture on the GPU. So we have two benefits here. So first of all, it's going to use less memory. Again, an application like Gmail will save maybe a megabyte of RAM, but when you see the number of processes running on a typical Android device, it's like, I think on my phone it's usually 30, 40 processes. It adds up. The other benefit is because all those assets live in the same texture, we can leverage a feature we added in 4.3 called batching and reordering and merging to limit the number of commands we send to the GPU. So this is an example taken from a Nexus 7. So this is how we render the list of developer options on that device using KitKat. So it's a little hard to see on the projection on the screen. But if you look at the checkboxes, we have an unchecked box and a checked box, which are normally two different bitmaps. But because now they live in the same texture, we can draw all those items at the same time. So typically that reduces the number of draw calls in applications, and I think we save something like 15% in typical applications like Gmail. So your apps just got faster for free.
If you have no idea what we're talking about reordering and merging, we gave a talk at Google I/O last year where we went into gory details into some of the improvements in the hardware acceleration pipeline.
The basic idea is that we don't do what you tell us to do. We reorder all the drawing commands in the application to make them more efficient for the GPU.
We've been recommending that people do that on their own as much as they could, but we can actually do it much more efficiently. So all those text elements spread throughout different views are all being rendered in the same pass. And that's not anything you could do in your application unless you made one monster custom view out of that, which would be horrible.
There are also other awesome graphics improvements that we made in 4.4. So the first one is called software vsync. Again, I won't go into too much details because there's no API, so there's nothing for you to do to benefit from it. But the idea is we are faking the vsync event to have the application start drawing a frame a little bit ahead of the actual hardware vsync event, and that reduces latency, which makes devices like Nexus 5 running 4.4 a lot nicer to use because that reduces the lag when you're doing things like scrolling or thinning. Surface Flinger is the window compositor on Android. It's always been using OpenGL 1, and it's now using OpenGL ES2.
So it's twice as good.
Well, it's more like 20 times the amount of code because of ES2, but it's not twice as good. So right now we're not really benefiting from it, but it's basically the foundations for awesome improvements in the future. There will be optimizations based on that, and we can also do full screen filters. So for instance, in the code, it's not enabled for users, but there's a system property you can play with, I think. So if you're colorblind, or if you have color vision deficiency, I don't know what's the political...
politically correct.
The politically correct term for that.
Color challenged.
Color challenge. we can correct for that a little bit, and that makes the entire UI a lot easier to read for people who suffer from this. And asynchronous texture uploads, it's really for applications that do a lot of text. If you do a lot of if you animate the scaling or the rotation of text, if you use a lot of emojis, or if your application is meant to be used in Arabic or Hebrew or Chinese or Japanese or Korean, locales with a large number of glyphs, we've made a large number of improvements, and your application is going to perform a lot better.
Render scripts. There were performance improvements for render script compute around, I don't even remember the specifics. Around everything, render script's a lot better.
So right now, depending on your device, on some devices, for instance, on the Nexus 10, render script will run on the GPU. So you're gonna see. I don't remember what the numbers are. It's maybe the equivalent algorithm is gonna run 100 times faster than the same algorithm running on Dalvik. On other devices that don't have the GPU drivers, we're going to use just multi-threaded implementation on the CPU, but it's going to take advantage of all your cores. So typically, from what I've seen, a simple algorithm like a blur, using render script running on the CPU will still be 2 to 5 times faster than the same code written in C and hand-optimized and multi-threaded. So it's really nice.
So the improvements are based on what we can do directly with the GPU, which requires some driver improvements, which means that I believe it's working on the Nexus, all the Nexus devices, 4, 5, 7, 10.
I wouldn't say all of them, but
I won't say it's not on the Nexus 1. I can promise that it's not working on the Nexus 1. I believe it was the 4, 5, 7, 10. Don't quote me. No one's recording this, right? And we're working with partners to get it onto other devices as well. So in the meantime, it behaves well anyway, and it takes advantage of multi-core, but on devices where it can, it will also use GPU and get even better performance.
Because you're so quiet, here's some C++ code for you. This is what, so now we've, in 4.4, we've also added support for render script in the NDK. So if you're doing a lot of native code in your application, now you can benefit from render script. This is code that's coming from the OpenGL renderer that we use to render the UI. And this is how we generate drop shadows. So it seems a little complicated. I won't go into too much details, but it's a lot of setup. The interesting part is here. We use something called an intrinsic blur. So basically, there's an algorithm for blurring that's built in, and that's super fast, and it's going to perform really well on pretty much all devices. Render script comes with a lot of intrinsics. So if you want to do something that's already supported by one of the intrinsics, you don't even have to write render script code. You can just use that intrinsic. Then it's just a matter of setting up the allocations and running the script. But yeah, so we wrote that code I think in 4.2. And that's what gave us a 2 or 3x performance boost when generating drop shadows for text. Systrace, how many of you have used Systrace before? Okay, so that's good, not good enough. We've made improvements, and let me run Systrace from monitor if I can find, how does that work? I hate multi-screen on Mac.
Chet in stereo.
All right, so I'm just starting monitor. This is the replacement of DDMS. Yeah, and I was talking about the number of processes running on an Android device. That's what's running on a Nexus 5 that after the first boot and I did not count. It's a lot of stuff. Let's see, where is my mouse? Here we go. So if you select the device, and there's this little icon here that looks like, I don't know, looks like a spiky alien thing. Anyway, that's this trace, so just click on it. Then you can select where you want to put the trace file. So let's put it on the desktop. And then you have to select what you want to trace. So typically, what's interesting for an application is to trace graphics, view system, Darvik VM, CPU scheduling, and CPU frequency. So just click OK, then start playing with your application. So I'm just in Launcher, and I'm just opening all apps and scrolling between the pages. When it's done, we have this HTML file right here. That opens in Chrome, maybe? Thank you, Chrome. All right. So for those of you who have never used this trace, we won't explain how to use it. I just wanted to show you some of the new features.
It should be obvious.
Yeah.
Can we move on?
Here at the top, you can see the CPUs that were active when I was playing with Launcher. So we had 3 out of 4 CPUs that were doing something. And if you zoom in on those timelines, if I can,
Using NetHack keys, I love it.
Yeah. If you zoom in on the timelines, you can see exactly what process was running on which CPU and when and for how long. Now, if we go at the bottom, we're going to see Launcher because Launcher was doing stuff. So one of the new tags we've added in 4.4 is to debug animations. So every time you see an animator tag, it means an animation was running. For some of them, we're able to know what the animation was animating. So here, for instance, the green animator was modifying the left, top, right, bottom, scroll X, and scroll Y properties of a view. And then you can match that, so you can see that for this duration, go to select mode. So everything that's in selection here at the bottom, those are the frames that were drawn for the duration of the animation. So you can see exactly what was happening during the animation. And if you zoom in, you're going to see that we're drawing, and you can see how much time we're spending drawing, stuff like that. We've also added, if I can find it, new tags to track inflation time. So if your app, if you're, come here.
It is like NetHack.
Yes. I can actually use the new controls for the mouse. But I can do it.
What's going on? You're not moving to the right. You need to move to the right.
Oh, yeah, I was zooming in and out on it. Yeah. Like I said, we're tired. If we just collapse on stage, don't worry. It's all part of the plan. There we go.
That was totally worth it, wasn't it?
Yeah. Anyway.
Look, it's a blue rectangle.
Pretty graphics. No, but here you can see that Launcher spent 1 millisecond inflating views, and you can see that it inflated something called the page indicator marker, an image view, and another image view. So if you're using systrace to profile what's happening while you scroll a list view, what we've seen happen in a lot of apps at Google is inflation will often be the cause of stuttering. So I think I've seen that many times for the past few years, but use fewer views. Ideally use one view, and that should improve your app. Anyway.
There's also tags for bitmap decoding, which is a large time sink for media-intensive apps. And it's also worth pointing out, not tied to KitKat, but we talked about this, I think, at I/O, that you can now create custom tags. So we plumbed the system with a bunch of information so you can sort of see what's going on at the framework level, but you can also find out what's going on in your app and have those events synchronized with the rest of the information in the systrace. So you can use the trace.java API to add your own tags.
And as usual, we were worried that we would not have enough content for you guys to fill 1 hour, and we still have like 25 slides to go through, so we're going to go in fast mode.
Actually, we should find out what time we're going to, because we started late, so I
doesn't matter, he deserves to do it.
Okay, all right.
Nicola is always late.
He's actually just starting to write his slides, so
new debug tool for performance. How many of you have seen the overdraw debug tool that was introduced in 4.2? I like people raise their hands. Everybody else, go read my article on the subject. So now we have a new counter. You can see in every window there's a little number that tells you how many times you've drawn the screen. and the color tells you if you're doing things the right way or not. So if it's green, you're doing great. If it's red, boo on you.
We had great feedback that someone said, how can that be a 0.7? How could a pixel be drawn 0.7? And we had to explain that's the average overdraw for the whole screen. At that point, you just stop the conversation and you move on. Fine. Overdraw is important. Okay, so this came up before. We were talking about how many gingerbread phones there were. It's a little depressing that there's still a lot of them out there. The main factor, we think, it's hard to talk to everybody in the world, is that gingerbread is known for having a smaller memory footprint. As we've added capability to the platform, memory goes up. And in cheaper markets or just situations where people want simply cheaper smartphones, it's hard to get the price down to a reasonable level if you have to jack the memory up to support a larger platform. So there was a huge effort called Project Svelte in Android KitKat where we focused on making the memory, the minimum memory, much smaller. So now we run reasonably on 512 megabyte devices. A few years ago that was considered huge, now it's considered small. So now we can run reasonably on these devices, which means that maybe gingerbread will accelerate its deterioration as people can actually release cheaper phones with enough memory to actually run Android reasonably.
So something that's important to know, when you have 512 megs of physical RAM, not all of that RAM is available to the apps in the framework. So typically after, because there's the radio that's going to use RAM and we need to do allocations for the GPU and drivers and stuff like that. So typically a device with 512 megs of RAM will have about 380 megs available to the apps. So when you see an application like, I don't know, what was it? Oh, Facebook on your phone was using what, 100 megs in the background without the UI.
Facebook.
So that's a third of the RAM right there. Makes it hard to run multiple apps.
So it was totally worth it. Did you see all those pictures of cats? They were so cute.
So it was a long and tedious process to go through the entire system. We went through the framework and we saved 10 kilobytes here, 100 kilobytes there. We went through all the apps and we chased down memory. We've had like a number of improvements at the system level to try to conserve memory as much as possible. We're doing, I think we're using ZRAM, so we compress memory in RAM. There's a lot of fancy things in the kernel to help. But because it was so difficult, when we were trying to go through that process, we realized it was hard to understand where the RAM was going. So we introduced two new tools. Actually, it's one tool and a UI for it to help you figure out like what's using RAM and when. So in developer options, there's a new entry called process stats. And Chet, tell us more about it.
So I should point out too, this is probably a tool that's a little more interesting to people on our team and the framework team because we look at sort of overall who's doing what on the system. But it's also helpful to see how your application looks on the system
Well, the short version is that if your app is at the top of that list, you should see a shame
going on. And there's also things like, are you creating multiple processes for your apps and are they all there? Do you have a service that's causing your app to constantly run in the background and soak up 100 megs? Even when the user wasn't actually interacting with it. These are all good things that you can find out from using this tool. So the UI here, it may be not obvious. So this is the Jamaican flag. So this indicates how much of the time during this 4 hours and 23 minute sample time that we measured over, how much was spent in, I think, critical memory and low memory and normal. Moderate? Normal.
Normal.
I think moderate is, okay. So these correspond to when your application, when your activity would get a notice to trim memory because of this memory situation, if you're familiar with those events. And then these are all the applications at the top of the bad list. This is saying that during this time, this application was running 100% of the time. And the blue bar doesn't indicate the percentage of time, instead it indicates how big it is compared to everything else. So of the things that were running a lot, this one has the heaviest memory footprint. And then you can click on these and bring up a detailed page that actually shows you how much memory these things were taking up. So download manager, which is not here, so this was taken from a different situation, wasn't taking up that much. If you click on something like system UI, maybe you'd see something more like 20 or 25 megs. I clicked through on Facebook earlier and saw that it was taking 99 megs. Bad thing, right? So just make sure that your application is behaving there.
Yeah, and if your service is running a lot, that might be a prime too. So when you click on your process, here you can see, why you are running so much. So for instance, the download manager was running 52% of the time over the sample period, and you can see that it was running mostly because of the MTP service. So that probably means that the device was simply hooked up over USB to a laptop, and the Android file transfer client was running. So that will give you a lot of information. You can see your average RAM use and maximum RAM use. So try to minimize your time running and the amount of RAM you're using. There is an awesome, long and very interesting document on d.android.com called Android and RAM that explains how to use this tool and why RAM is important, and gives you actual number of so if you use collections in your app, or if you use extra libraries, it will tell you how much overhead you're adding to your app. So go read that document, it's really, really useful.
Lots of information about meminfo, which is another good tool to use for similar sort of
we can skip that
information. Yeah, it's a non-UI version of the same kind of data from Proxstats. And finally, there was a new API added specifically for the Svelte work. If you want to make sure if you want to degrade your experience so that you don't take up too much memory on low memory devices, or if you otherwise want to know what's going on and do the right thing, there's a new API you can say is low RAM device, and then change the experience or change your logic appropriately.
So connectivity in media. This is the section where we pretend we know what we're talking about.
Not very well.
So stay with us. So first of all, we've added support for HOCP. HOCP is awesome because it's an acronym that's made of acronyms. So HOCP means HID over GAT. It's for Bluetooth.
So low latency peripheral devices.
Yeah, that's the human being version.
But I just like the fact that there's 3 acronyms to describe that one simple concept.
So the way I would describe it is if you want a mouse or a keyboard that works quickly and doesn't use too much power, HOCP is awesome. IR blasters, there are phones out there that for some reason can act as remote controls for other things like a TV. So now we have APIs for that. So if you have one of those devices, you can write code for it. NFC, that's actually, that one's pretty cool. Testing NFC was pretty difficult because you need a lot of hardware around you to do it. Now you can emulate NFC host cards in software to test your application. We also have new low power improvements for sensors. So we do a lot of batching of sensor events to consume less battery. And we have new logical sensors called step detection and step counter. So if for some reason your application wants to know if the user is walking around and how far she's walking, you can use those new sensors, and they're very power efficient. If you're doing a lot of video playback, we now support adaptive playback. That means that at any time during the playback, you can change the resolution of the video stream, and it will be seamless to the user at the UI level. So you don't have to do anything except change the resolution of the stream. We've also added
loudness enhancer.
I was hoping you wouldn't try that. So here the idea is that you can increase the audible volume of a given audio track or a media player. So typically, if you're playing a video and you have a track for dialogues, for instance, and you want to make sure they're audible over music, you can use new APIs to do that. Image reader, it's an API that's been requested for quite a long time. This gives you access to the content of a surface. So the idea is you create an image reader, you give it a width and a height, you indicate the number of buffers you want to be able to keep in memory, and you set up an image available listener. So then from the reader you can get a surface, and with a surface you can do many things. You can render a video into a surface, you can display the camera preview, you can render OpenGL, and every time you push a new frame to that surface, your on image available callback is invoked, and from there you can get access to the data that composes of the image. So typically, if you want to do image processing, you can start playing a video, and then you can grab every frame and do whatever you need to do with your app.
Next up,
speaking
one
of video,
my favorite features in the whole release: screen record.
Right on time for me to not give talks about Android anymore.
You can come back. I'll see what I can do to set up an interview for you. So, screen record allows you to take a recording of everything that's going on the screen. I use this a lot for debugging. It would also be very useful for like a tutorial on how to use your application. You can enable touches, so you can see where the user has touched their finger during the actual interaction on the device, and it basically takes a snapshot of every screen, every changed screen of information, and dumps it onto a file where you specify in the device, then you pull it over. It's an MP4 file. The way I debug is you can pull it into QuickTime on my Mac and then just step frame by frame by frame. It's a lot easier to debug animations when you can actually look at each frame instead of just watch this thing fly by and wonder what happened.
We used to do that with dedicated HDMI capture cards in our Mac Pros.
Yeah, and high-speed cameras, and this is so much easier.
I mean, in terms of UI, that's not great. So if you have the latest version of Android Studio, there's a hidden button. It took me a while to find where it was. So there's a tab here called Android. It's tab number 6. And there's this little play button. That should be a record button, really. So if you click on it, you get the screen recording dialog. You can specify the bitrate of the video, so you can record, and you don't have to specify the resolution. But if you're recording on a Nexus 5, so Nexus 5 is a 1080p device, if you want to render at 720p, you can specify the new size here. The good news is that you can render in really high quality, so you can try to render 15 megabits per second at 1080p, and you're going to get a great 30 fps video out of it.
Apparently there was some more stuff that we didn't really have convenient categories for, so we'll blow through these.
So that, it's very important. There are a lot of smart people who focus on security, and so they did that. So you know, people who care, like there are a lot more details on the Android.com website. If you're interested in security and how it impacts your application or how it impacts the system itself, go check out the details on the Android.com website. The one that's actually interesting for users is if you have a tablet with multiple users, you can have different VPN accounts for every user.
There are several language improvements, language features that you can take advantage of now. We'll give you a little bit of detail at the end, but we'll walk quickly through them. The diamond operator, so you no longer have declarations that are too long for your line wrap. You can abbreviate on the right-hand side. Wouldn't that be nice? Switches on strings. This one is this the closable?
Yeah.
Yeah. So this one is important to note. All of the language stuff that we're talking about here, you can get on any level of the SDK. Basically, it's syntactic sugar as far as Dalvic's concerned, and it can do the right thing. Except for this one, you actually need Target SDK 19 to take advantage of the auto-closable.
Actually, you haven't explained what it is.
Oh,
how many of you do know what that does? Okay, so just a few. So you know, usually when you use, let's say, an output stream, so you create the output stream and you have to catch the I/O exceptions, and then in your finally block, when you're done writing to it, you have to close the stream. But closing the stream can throw the exceptions, so in your finally block, you have a try-catch. And if you have several streams, then you end up with like those incredibly nasty, nested try-catches of I/O exceptions. So the new automatic resource management will take care of all that for you. So any instance of an object that implements the interface called auto-closable, which contains only one method called close. So you can specify that instance in the try statement, and when you exit the try-catch block, it will automatically be closed, so you don't have anything to do. Makes code a little easier to read and to write.
And catching multiple exceptions instead of having exception, or what everybody does, you just catch generic exception. Which you shouldn't, but we all.
All those are available if you download the latest version of Android Studio. I think it's 0.3.3.
3.3. I think it was actually coming out today. And you also, if you're on a Mac, you also need to install Java 7 to take advantage of those. So 2 important things to actually get these. Otherwise, go play. New
little bonus.
Yes.
A new runtime. If you go to developer options, there's this new option called select runtime. And you can choose something called Art, which does pretty much what Dalvik does, that is, it runs your applications, except it's completely different. So you can try it. Don't try to run your device all the time with it, because there might be bugs. But if you want to test your application and give us feedback and found bugs, by all means, like, go check that option. Once you've enabled art, the device will have to reboot. It might take a little while to reboot the first time because it has to reprocess your all the installed applications in the new format. Yeah, you'll be able to try it in your runtime. That's probably going to ship sometime in the future. If you want to know more, this is a playlist of DevBytes videos compiled by our friends in developer relations. So those are short videos, like five-minute videos that go into more details about some of the stuff we talked about here, like closed captioning, the new storage framework. So if you want to know more, go check out those videos. And of course, the release notes for KitKat.
And finally, we tend to talk about this kind of stuff, or you used to in your former life.
Yeah, I don't think I will talk much about Android on my blog.
There's some fantastic articles, especially on performance. There's a great use case on overdraw and using the tools to chase down performance problems on his blog on Curious Creature. I talk about this stuff occasionally on mine, and we're also both maybe obviously on G+, as well as Twitter. If you want to follow us there, we tend to push stuff.
And we'll take a few questions.
Probably not many, because
well, Nicolas seems busy.
I have to go to bed. Yes.
Yeah, you mentioned these low memory methods. Does this take in account the shared library that you load and the amount of memory that you allocate through native call?
No, so islow.
It's for the device.
Islow memory is for the device.
It has nothing to do with your activity.
Okay.
It's the device will always return the same answer for that method called.
We do have an API that it's a callback. It's a listener you can set on activity that will tell you when the system is running low on memory. So we have different levels of low memory. And you should implement that callback to free up memory when you go in the background so that you don't get killed.
So
In
this
fact,
is for the whole system?
Yes.
Okay.
We implement that internally for things like GPU resources because it takes up a bunch of memory to upload textures and buffers and stuff like that. So we listen for those callbacks, but you should do the same in your activity, especially if it's very media rich.
I think you're not the only one going to bed.
So I think we put them out. I guess that's our talk. Yes? No? Oh.
It's okay.
Sorry.
Go ahead.
The Chromium WebView, we need to create Chromium WebViews and WebViews for all the SDKs.
So Chrome WebView, do you have to support to create a Chrome WebView and a normal WebView?
Yeah.
No, the Chrome WebView is just a replacement of WebView. So it just if there's a different behavior, you can treat that as just a new API level, and that's it. It's not an opt-in. The APIs are the same. There are a bunch of deprecated APIs that we switched to Chromium, but there were APIs that were kind of broken and nobody was using anyway. So.
Yeah, so to be clear, you don't need to do anything in your application, right, in your code. The web view you get will be the Chrome web view.
Cool, great.
Yeah. It's magic. Yes?
What about the stock browser in Android?
What about the stock browser? So Nicolas worked for a long time on browser and can tell you all there is to know about it. He's giving me a really
excellent question for the next speaker. And what a beautiful segue to the next talk.
I mean, the stock browser is just there in iOSP. It should work with the new WebView. The new WebView is supposed to be backward compatible with the old WebView. If you actually encounter some bugs or some differences in behavior, I strongly encourage you to file bugs because the team there is really trying to get things as close as possible to the old behaviors. More likely than not, if you have problems with the new WebView, it's probably that you're doing some bad stuff that probably is my fault considering I worked on the previous one. Yeah, that's about it.
Right. So there's and there is no more work on the stock browser. So it's whatever was the last version we shipped. That's what's in iOS.
Yeah. Anything new in support library? Those cool features that we see.
As I said, the transition stuff is still in the back of my brain, so that's not new there. I don't know. There is accelerating stuff in the support library. I would say the richer the platform gets, the easier it is for us to add features outside of platform releases. So there's definitely a big focus on adding stuff there. I don't know the details.
I think there is. I think I might be wrong, but I think there's something that there are helpers for printing, so that it will automatically like not print if you don't have printing support.
The document stuff.
Documents.
Part of the document provider stuff made it into Spoil Library as well. I don't know if it was all of it.
Yeah, I actually wrote that. So you can actually
Oh.
simply send a bitmap to the print helper, and it will just print the bitmap nicely.
That was on the printer, right? The document stuff, though, I don't
The
know.
document stuff, was working on it. I think Devrel is putting up some demos about that.
Okay.
Where you could just pass a view hierarchy, and it will just print things nicely.
I mean, as usual, we put as much stuff as possible in the support library. If something doesn't go in, it's most of the time because we just can't.
And there was one other one. Yes.
Yeah, what's the point of the new runtime art? Is it faster than Dalvik or?
Well, that's why you should try it to see what happens from that. So the new runtime is ahead of time compilation. So it will pre-compile your app. So it should be faster in some cases. It might be slower in others than Fireblocks. And let us know like, what should be put.
It's ahead of its time. Okay. I guess that's it. Thanks. Thank you.